Hello, we're going to look at polynomials inequalities day 2. Okay, given the function fx equals 4x to the power 4 plus 4x cubed minus 35x squared minus 36x minus 9, find all values of x such that the function is greater than 0. Use your knowledge of graphs and algebra to help find your answer. Okay, so this is a little different. We're not going to use the factor table because it says use our knowledge of graphs to find the answer. So first thing we're going to do, we're going to have to use factor theorem. If we go down the list, we got all the way to factor theorem. We know that with the constant number being 9, the possible factors are plus or minus 1, plus or minus 3, plus or minus 9. And we go through them and figure out 1 doesn't work, but 3 does. So F3 works. That's going to be factor number 1, and let's divide everything by 3. 4, 4, negative 35, negative 36, and negative 9. Okay, so then we're left with 4x cubed plus 16x squared plus 13x plus 3. Because all of these are positive, we know the next factor is not going to be positive, so let's not try 3 again. We'll go to negative 3, and negative 3 gives us an answer of 0. So we know that negative 3 will be a factor. Again, we divide. And again, reminder from the start of this unit, you can use long division to divide, but for the sake of the videos, I typically use synthetic just because it's quicker. Okay, so we're left with 4x squared plus 4x plus 1. Okay, the factors of, well, 4 times 1 is 4, that add to 4 are 2 and 2, so let's split that middle 4x into 2x and 2x. We're going to group. So we get 2x with 2x plus 1, plus 1 with 2x plus 1. Okay, we could have looked at 4x and 1, realized that they're perfect squares, and that would have worked. Or we just get 2x plus 1, 2x plus 1. Which is the same as 2x plus 1 squared. Okay, so there is our final x-intercept. Okay, so we have factors of x minus 3, x plus 3, and 2x plus 1 squared. And reminder, it's the opposite of what you see. This represents 3, this represents negative 3, and negative 1/2. Okay, those are the x-intercepts that we'll graph. Okay, so now we use our knowledge of graphs. When you're making your own graph, you don't have to have all the ticks. We just really need the pertinent information. So there's, put in a few. Okay, we're going to say 3, negative 4. Let's go to 4 this way. And really the only y value that we know is negative 9, so let's just throw it down here. Okay, so what do we know to graph? Well, we know that there is an x-intercept at -3. We know that there's an x-intercept at +3. And we know that there's one at -1/2. And then we also know the y-intercept. Okay, this is an even degree, a degree of 4, so the arrows will be going the same way. And it's a positive leading coefficient, so they'll both be going up. Okay, so we know that for sure. And the other information we know is at -1/2, we have a multiplicity of 2, so it's going to go like this and turn around. Okay, so that helps us. We can go through like this, connect our lines. We know it goes all the way down to -9 and then up at +3. So this is a possible graph. Now, the answer, or so the question, sorry, is saying when is the function greater than 0? So the intervals where it's greater than 0. Okay, so therefore, f of x equals 4x to the power 4 plus 4x to the power 3 minus 35x squared minus 36x minus 9 is greater than 0, greater than or equal to 0, when x is less than -3 and when x is greater than +3, right? Because the only two parts where it's greater than 0 are here and here. Everything else is under the x-axis. Okay, and then reminder, you can write it like this. Oops, sorry. Or you can write it where it's -infinity to -3, +3 to +infinity. Okay, they're both acceptable. Okay, next one. Given the functions fx equals 3x cubed plus 2x squared minus 6x plus 11, and gx equals 2x cubed plus 3x squared plus 11, determine all values such that the first function is less than the second function. So even though it doesn't say use our knowledge of graphs, because we worked with an inequality using the factor table in a previous lesson, we're going to use a graph to determine the answer in this. Okay, so first step is we need to make the equations equal to each other, or we put a less than sign. We want the first one to be less than the second one. And we're going to move everything from the right to the left. So we're getting rid of these by doing the opposite operations. So we're subtracting 2x cubed, we're subtracting 3x squared, and we're subtracting 11. There is no singular x's. So we get an equation of x cubed minus x squared minus 6x minus 10 is less than 0. Oh, sorry, it was 11 and 11. So my mistake, I just wrote it down wrong. It actually ends there. 11 take away 11 is 0. Okay, so first thing we're going to do, we need all the x-intercepts. First on our old list is there a greatest common factor? Yes, they all have x's. So step one, let's take the x out of it, and we'll be left with x squared minus x minus 6, which is a great equation to factor the factors of 6 that subtract to 1. We're going to leave that x there. We'll get x minus 3, x plus 2. Okay, so the factors for the graph are 0, 3, and -2. Okay, now we'll draw our graph. Okay, if we look back at the equation that we created by moving from the right to the left, there's no constant value, right? And so that means that the y-intercept is 0, which is great because one of our x-intercepts is also 0. All right, let's create a graph. We know it has to go as far left as -2, as far right as +3. Whoa. And we don't really need to put y numbers in because we have our y-intercept at 0. Okay, so we have those x-intercepts, -2, 0, and +3. And the multiplicity for each of them is 1, so it's going to go straight through. Okay, it is a cubic, so an odd degree, meaning that we will have opposite end behaviors, and it's a positive leading coefficient. So it's going to start down, end up. Okay, and then again, we're not in calculus, so we don't know the turning points yet. Okay, so there's a possible equation. Now, it is asking us when is f of x less than g of x. So when we made it into one equation, it has to be less than 0. And we see that it's less than 0 here and here. So therefore, f of x is less than g of x when, so we could put -infinity to -2 and 0 to +3. Okay, we make them the circular brackets, the normal brackets, because it's not less than or equals to, it's just less than, so it goes up to the numbers, doesn't include them.